Hey, welcome back in the shop. This is the second episode on the power feed for my milling machine. In the last episode we did the sleeve. We made the sleeve with the keyway in it, and this time we make the movable clutch piece that goes over it, that will slide on it. And I did most of the turning off camera because it's just outside turning, grooving and drilling. And now we're going to part it off so we can finish it from the inside. I already drilled into it with a rotor broach, but as it's the nature of the rotor broaches, there is still the plug in it because it's a blind hole. Here you can see the plug that's left by the rotor broach. When I'm going to part the piece off, it's going to separate from each other. Okay, the part is still riding on the plug from the rotor broach. That went very well. This inserted parting tool produces quite a nice chip. Okay, I got all the turning done. This is the sleeve we made in the last video. This is the movable clutch. These two pieces slide together quite nicely. And we have the motor clutch already set up in the 4-jaw chuck on the rotary table. And now we can machine in the clutch, the clutch teeth itself. I machined the motor-sided clutch off camera, because I was not sure how this works out, and I want to concentrate on the process itself and not do machining and camera work at the same time. But of course you have a second clutch to machine, and I will show you on camera how I did this. Hang around until I have the next part set up, and then we will be back. Okay, I centered the workpiece in the 4-jaw chuck. Now we can start to machine the teeth. We go down 5 millimeters and do our roughing cuts. Clamp the quill, clamp the y-axis, clamp the table here. Okay, let's go. First one, now we go 45 degree on. That's all the roughing for the first side. Now we can finish them by offsetting the table back to 1.75. This is a 3.5mm end mill, so half the diameter is 1.75, and that's the offset from the center. But I start my finishing pass on the inside. First I go conventional milling, and then I return on clamp milling. Okay, we're back at the first gap. We finished all these sides of each of the gaps. Now we move the table. First we move out and go down 2.5. Go down 5mm again. Okay, that's the right there. Now we can. Now we start at 22.5 degrees. Sorry. Or 22 degree 30 minutes, but I prefer to work in decimal angles. For me that's easier to understand. And now we move the table the other direction. And now we rough out the other side. Okay, we have the clutch finished. We did a finishing pass on all the teeth, and now we can test fit our two clutches, and of course they're not anywhere near fit, and that's because, yeah, I machined both sides with zero clearance, and as the end mill is always somewhat undersized, you could press these together with an hydraulic press, but not a nice sliding fit. So we have to give each of these teeth a bit more air. We will remove maybe 5/500ths of a millimeter of each side, so we get a nice light fit. Okay, I removed 2/100ths of a millimeter. No, in fact, 7/100ths of a millimeter of each side of each of the tooth, and now I get a super nice light fit. And that will do it for the clutch of the Powerfeed. This is somewhat of a nice, I like it. It's a bit fiddly because you need to be on center and the teeth needs to be meshing. So this is interlocking in 2 axes, but it has a little bit of play. That's good, but because that's what makes it later possible to engage the clutch. Okay, we're over at the shaper, and I set the workpiece up on my angle plate against the parallels, so I have clearance behind the part where the slotting tool can move through. And I'm using a 3mm slotting tool. I want to cut a 4mm wide slot, and for that reason I have my dial indicator down here, so I can offset my work 0.5mm in that direction and in that direction. I will go down 2mm, back off, set over 0.5 in both directions, and cut down again, so I get a 4mm wide slot. What else? I already centered my workpiece to my tool to the workpiece, and everything is aligned. I'm ready to go. Okay, let's hand crank it again. Okay, dial is zeroed and we're good to go. Everything's locked. Okay. Okay. Okay, now you're looking down through the slot in the angle plate into the workpiece, and back here where my finger is you see a set screw. This is the screw in the tool that holds the tool bit, and in that setup you will see how the tool is shaping away the material. Set the tool 0.5 millimeters to the side, and now we take the second cut. Okay, we're down 2 millimeters. I finished the slot on both sides, and I test fitted my brass key material, and I need to retract the tool a bit more, and it seems to fit very nice. Pretty, yeah, this is a good fit. I want it to be on the tighter side because I still can adjust the fit by filing the key or by filing the actual keyway. So that's okay. We can tear down this setup. Okay, I decided against a keyway in the motor-sided clutch because I would have to shape a 22 millimeter long, 3 millimeter wide keyway in a 10 millimeter bore, and I don't see an easy way to do it. The tool for that purpose would be very flimsy and prone to deflection, so I decided not to do a keyway and only rely on 2 set screws. I'm going to do 2 set screws about 180 degrees apart. Not 180, 120. This is a starter drill. I started to use an 120 degree starter drill because the drill bit has an 118 degree tip, and when you run this in a 90 degree spot drill spotted area, you're going to chew up your cutting edges of the drill bit, and start to use a 120 degree. That's much more like a normal drill bit, and that works very well. Okay, let's drill. And I'm just indexing it by eye. I'm not going to set the rotary table in horizontal mode. Okay, that's the tap drill, and now for the 4 millimeter tap. We'll use some cutting oil, low speed. Okay, that's 180 RPM. Okay, I just love power tapping. This is way more civilized than turning a tap by hand. It's faster and it gives better results. As you can see here, first I tried to make the keyway by plunging down with a 3 millimeter end mill, but that was no good idea. Okay, let's okay, these are 0 and these are about 180. And I set up my stop so I don't have to relocate with the edge finder. Okay, indexed. Look at these beautiful chips these sparrow flute taps produce. Unfortunately, I want a part, not chips. Okay, we're over at the milling machine again, and I made a brass key. I machined a piece of brass down so it fits snugly into our sleeve, and I mounted the sleeve with 2 set screws on the shaft, and here we have the sliding coupling or sliding clutch, and this fits very nice without much play. The clacking noise is in fact the hand wheel on the other side, but this is pretty nice, and this is working very well. I have also mounted the clutch to the motor, and that works also. And I deburred all the parts and rounded the edges over slightly, and now the clutch is engaging very nice. So in fact the motor would be here and the clutch would be pulled over until it engages. And what we can do now is that we hook up a power supply to this motor and see how it drives the table. Okay, I will just hold it up by like this and run the motor, and as you can see, it's driving the table quite nicely. This is a 24 volt motor, but I'm running it right now at 17 volt. This is the maximum this power supply can deliver. But that feels like a good speed. That if we change the polarity, of course, we can go in the other direction. And the Powerfeed, of course, will give us a very nice finish when we're doing facing cuts, or when we're cutting a long slot and don't want to turn the crank all the time. That gets odd pretty fast. And I will set up a PWM motor speed regulator, but just by turning down the voltage I can get a very nice fine feed here. And as soon as I have a housing for this motor and the clutch, this all will work very nice. So that's it for the second episode. Thank you for watching, and see you next time when we build the actual housing of the power feeder.